Okay, welcome back, Programming 12. We are going to now try to destroy bouncers. We would like bouncers to be removed from our array list, and our array list to shrink down to 0. So what I'm going to do is I'd like to make it so that one side of the screen is going to kill our bouncers. So I would like to create a new instance variable that will keep track of whether my bouncer has died or not. So that's going to be right here in my bouncer class. And I kind of don't need my other bouncer anymore, so I'm going to close the array version because it's sort of not really important to the rest of this demonstration. Maybe I'll also shrink this down a bit so I don't have to go back and forth. Yeah. Okay, did it. So I'm going to add in a new variable that keeps track of, is this bouncer alive or dead? It's going to be a Boolean variable, and it's going to be called alive, I guess. Also, a decent thing to put in here, instead of a Boolean variable, maybe it would be a hit points style variable, int HP. I think that actually might be a better way. Let's do it that way. Nothing wrong with the previous one, but I think having hit points would be a kind of nice idea. We'll just have all the bouncers have 1 hit point, and they'll die when they have 0 hit points. So that's our new instance variable. All bouncers have a HP value, using some nice gamer terminology. When we create our bouncers, we should probably give them some hit points. I'll just give it 1 hit point, and that's going to be sufficient. And I think we're good. I guess we're not. We have to have it also lose hit points. So what should we do? I think I go program it in for maybe when it hits like one of the walls. Maybe when it hits the bottom wall of the screen, we can have it die. So I'm going to keep it bouncing off the left and right wall, and I'll even keep it bouncing off the top wall. But for the bottom wall, oops, I kind of want to keep that logic there. I'm going to make a new if statement. So I'm going to say if it hits the bottom wall, what I'd like to do is set hit points to, we could either say hit points minus minus to drop it by 1, or we could just set it to 0. That would be fine either way. Maybe I'll do it like this. I think that's a good way to do it. So I'm still bouncing off the left and right wall, and I'm bouncing off the top wall, but if I hit the bottom, hit points goes to 0. Now, just to be clear, hit points is not some special variable. Processing has no idea what hit points are, even though you do as a human. Like, it doesn't care. So for me, the result of this is going to be the same. They'll go off the screen because they no longer bounce. Oh, wait, they don't. What's that all about? What? I didn't expect it to hit the bottom there. Let's see what happened there. So bouncing off the top and bottom, they hit there, and they actually slow down so that they're kind of stuck. Oh, yeah, I forgot. We have some limit code. Remember we have these limits here, prevent the bouncers from getting stuck. So they don't go off the screen. That's okay. We could either turn that off, or we could just leave it there. It's fine. You can just leave it there. Sorry. But yeah, I would like them not just to get stuck on the bottom. I would like them to be destroyed, as if the bottom was like a pool of lava. You can see that if they get stuck on the bottom, they can jump out from the bottom when they get collided with. So it's really not good enough just to stick them down there. So let's do it. So hit points didn't do the job on its own, because hit points doesn't mean anything on its own. We have to check for bouncers that have 0 hit points and then remove those bouncers. And we're going to do that over here in our main tab. It's right here in the draw function. In our main tab, I would like to make bouncers act and show. And if there are no hit points in that bouncer, I would like to remove that bouncer. So here's how I'm going to do it. I can say, hey, go ahead and act and show, and then I can ask if bouncers.getI .hp equals 0, then I can say bouncers.remove I. So what's going to happen is if the bouncer on page I has 0 hit points, we're going to remove the entire page. We're going to rip that page out of the list, and that bouncer will be gone. Now, if you rip a page out of a book, unfortunately the numbering system gets messed up, right? Like if you tear the middle page out of a book, it doesn't reorder the numbers for you, but it does in processing. So if you tear out a page, no big deal. It'll renumber all of the things. So that's good. But there is a problem. When you tear out a page, it renumbers it. So if you go to the next page, well, you're in trouble because you're going to skip over one of your bouncers. So there's a couple ways to solve that. Either you could choose to remove it or go to the next page. Because if you kind of tear out the page, I is now the next page. This is referring to the page afterwards. So you can either do it sort of like if else. This would be a good solution. So either tear out the page and then they're all renumbered, so I is ready to go as the next page, or go to the next page. You could do it that way. Another way people do it is like so. They might say, well, every time we tear out a new page, oh, sorry, I got my braces messed up. Every time we tear out a page, we'll also I minus minus to make sure we sync our page number with the actual numbering of pages that's in the list. So because remove reorders the page numbers to account for that page being torn out, we have to account for it too. So which way do you like better? It doesn't really matter to me which way you do it. I don't know. I guess I'll say it like this for my code. I think that'll be fine. And now if we run, we'll see that they'll actually go away. They'll actually get deleted. So I'm going to pew, 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 make a bunch of things. And look, they look like they go off the edge of the screen, but they're actually getting destroyed. And now, maybe actually I'll stick that this in our loop again, back in draw. I'll just stick it at the very beginning, the top of draw. So remember how it was causing our program to lag before? Now, it'll keep on going. It goes wherever the mouse is. But it'll eventually cap out at a certain number because they're being destroyed as well as new ones being created. So we're never going to fully lag it out because, well, I guess I don't know the rate of increasing. If I put my mouse down at the bottom, they're being created faster than they're being destroyed faster than being created. So then, I'll eventually kind of dwindle down to very few. And you can see that's getting lesser and lesser. If I put it at the top of the screen, it'll take a while for those to get down to the bottom. So this will fill up with more and more, and we'll probably lag out. The rate of increase, I feel like this is a chemistry class now. It's like thermodynamics or something. It's the rate of increase. Is this exothermic or endothermic? Where you put the mouse kind of is controlling the state of this system. But anyways, you can sort of see the idea that we can now create and destroy objects based on sort of where they're ending up. A really basic example would be, to further this example is, hey, what if we didn't do any bouncing? What if we just said HP is 0 no matter what edge we hit? If I go to my actual class and I'm just like, kill anything that hits a wall, they're still going to bounce off each other, but then they'll immediately be destroyed as soon as they hit the wall. So they won't last very long at all. Sometimes they'll hit each other on the way over there. But yeah, they're definitely not going to be too many here. We'll probably get to some limit of how many we've created, and then they'll start being destroyed. So we'll never have too many. They're not flying off the edge of the screen and still existing outside. Because I am removing them from the list. So the list is able to grow and shrink to accommodate all these things. All right. Well, thank you so much, folks, for checking out ArrayLists. So I bet you could come up with some fun things to do with array lists, and I'll show you an example of something that you can do in class. I'll give you sort of an extension activity to try out. Okay, so stay tuned for that, and I hope you enjoyed watching the videos, and I hope that that made sense. I totally acknowledge, though, that this is our first time seeing array lists, so it will probably feel a little bit confusing and complicated, but hopefully you're able to get this project to work, and you're on the road to understanding how array lists work. Okay, so thanks so much for trying your best, and we'll talk to you soon. Bye-bye.